We would now like to find how to find the determinant of a square matrix. Let's first of all start off with a 2 by 2 matrix and go back to form 5 where we learned that if matrix A had elements A, B, C, D, then the determinant of A, either denoted by det A or the mod of A, that is equal to AD minus BC, or the leading diagonal, the product of the elements in the leading diagonal minus the elements in the other diagonal. Okay, so it's AD minus BC. Now when it comes to a 3 by 3 matrix, it's a little bit different. So let's say we have our matrix A, and we have elements A11, A12, A13, A21, A22, A23, and A31, A32, and A33. Now we have to look at a few things before we go ahead or go about the process of finding the determinant of this matrix. So one of the first things we have to look at is something called the minor of a matrix. So the minor, let's say, of the matrix Aij, and we're going to denote this minor as the modulus of Mij. So it's the modulus of the matrix. Now, how do we get the Mij? Now the Mij, let's say M11, this is found by removing the first row and the first column. So if you cross out the first row and the first column, what do we remain with? We remain with A22, A23, A31, and A32. So the determinant of that minor is really A22, A32 minus A23, A31. Let's now find the minor of M12. And we're going to be removing the first row and second column. So if you remove the elements of the first row and then the second column, what do we remain with? We remain with A21, A23, A31, and A33. And the determinant there now, it's A21, A33 minus A23 and A31. In a similar manner, if we find the minor of M13, we would get, again we're going to remove the first row and the third column. What do we get? We get A21, A22, A31, and A32. Again, the determinant there is A21, A32 minus A22, A31. Now, what we also need to establish as well now is something called the cofactor or the sign the minor. So the cofactor or sign the minor. Alright, of Aij. Now the cofactor is denoted by alpha ij, and it's equal to minus 1 to the I plus j by MIG. So let's say alpha 1, 1, that is equal to minus 1 to the power of 1 plus 1 by the minor of M1, 1. The minor M1 answer is just now M1, 1. Alpha 1, 2 is equal to minus 1 to the 1 plus 2 of the minor of M1, 2, and that is equal to minus the modulus of M1, 2. Then alpha 1, 3. Similar manner is equal to positive now because it's minus 1 to 3 plus 1 is 4, so that's positive. It's the determinant of this matrix when we remove the first row and third column. So now, how do we find the determinant? The determinant of A is equal to A11 alpha 1, 1 plus A12 alpha 1, 2 plus A13 alpha 1, 3. Or, so this is more or less expanding the determinant of the matrix along the first row. But we could also do the same thing along the second row. So it's A21 alpha 2, 1 plus A22 alpha 2, 2 plus A23 alpha 2, 3. And we'll also do it along the third row as well. And so we end up with this. Let us note 2 points very quickly before we do an example. If a row or column in a matrix is a scalar multiple of another row or column, then the determinant of the matrix is 0. So once we have scalar multiples occurring, whether it's in row or column, the determinant is 0. And if a matrix has a determinant of 0, then it's singular. And if its determinant is not equal to 0, then it is non-singular. So let's look at some examples now of finding the determinant of a matrix. So let's go back to the original example that we had. We had the matrix A, which was A, B, C, D. So the determinant of this matrix, based on 2 rows, 2 columns, is A11 alpha 1, 1 plus A12 alpha 1, 2. So alpha 1, 1, right, we're going to first of all remove the row and column with the first row and first column, right? So this is now minus 1 to be squared of the determinant of M11, which is really minus 1 to be squared by D, which is just D. Then alpha 1, 2, it's minus 1 cubed, the determinant of M12. And what we're going to do now is remove the first row and first column, and we end up with C. So it will be negative C. So hence the determinant that we were trying to find initially, the determinant of E, that is equal to A11, which is E, by alpha 1, 1, which is D, plus A12, which is B, by alpha 1, 2, which is negative C. So we end up with AD minus BC. Let's go to another example. So let's say we have the matrix A, and this is equal to Sorry, let's use b instead now. B, which is equal to 1, 2, 3, 2, 3, 2, 1, 2, 2. So first of all, let's go and find our cofactors. Alpha 1, 1, so we're going to knock off your first row, first column, and this is equal to minus 1 to b squared into 3, 2, 2, 2, and that is equal to 3 2s are 6 minus 4, which is 2. Alpha 1, 2. We're going to now take off our first row again, but second column now, and we remain with minus 1 into 1 plus 2, and then we're going to get 2, 2, 1, 2. And that will give us negative 2. And then alpha 1, 3. We are now going to knock off our first row but third column now, and we remain with, so it's minus 1 to the power 4. We remain with 2, 3, 1, 2. And that is now 2 minus 3. Sorry, it's 2, 2. So that's 4 minus 3, which will give us 1. So the determinant of A, again, is A11, alpha 1, 1 plus A1, 2, alpha 1, 2 plus A1, 3, alpha 1, 3. And that is equal to 1 by 2 plus 2 by negative 2 plus 3 by 1, and that will give us 1. So that's 2 plus 3 is 5 minus 4 is 1.